So storm overflows in particular, alternatively referred to as CSOs, have been a preoccupation of the Urban Drainage Group since at least the early 1990s, with the development of the Urban Pollution Management Procedure. The investigation and design of solutions for CSOs has been a firm fixture, albeit cyclical, in the careers of so many of our membership, myself included.
I'd like to start by thanking you for the opportunity to share some of the work we've been doing on storm overflows and through the Storm Overflows Task Force, but also for the opportunity to learn from my fellow panelists and the audience. This is particularly appreciated in these days where some of us are spending so much time working from home. There are over 15,000 storm overflows in England, and you can see some on the map on the right. Of these 15,000, over 12,000 have event duration monitors, and of these, over 8,000 provided data in 2019.
What are the big goals for drainage, and how do we achieve them? I think we'd all agree, essentially, we're talking about avoiding flooding for people in their homes and businesses, and stop polluting, as we've been hearing about already today.
Complex hydraulics, we've talked about some of them, like Stoke and Scunthorpe to an extent. We also had the issue in Hinckley where the sewer and the river interacted with each other.
The session will address several key elements of our management of urban drainage flows, considering the impact of climate change on the rainfall experienced, our ability to translate rainfall into realistic impacts for customers, companies and national scales, informing the flood resilience metric, and finally calculating the community and flood risk in real time.
The final section in part A is the one that I feel most passionate about, and that's about the maintenance of models. We invest so much into the building of any flood model, and particularly into an integrated urban drainage model, that it's really vital we think about how those models are maintained and managed in the future, and to have those thoughts early on and not just as an afterthought. Now, I think the only thing I'd add to that is to make sure you remember the purpose of the modelling and what your actual study is. If you're looking, for example, at creating some storage in an upper part of the catchment to alleviate flooding, then you might be considering different types of durations than if you were building a small wall to manage a bit of surface water runoff. So always tie it back to what the purpose of the project is.
And just a graphic that's just really emphasizing how the modeling capability that's coming on stream now is able to better look at some of these complicated processes that are actually important in deriving these future changes in storms. So.
And taking my inspiration from Dave Terry, I went out with a large bucket and a stopwatch and tested all of the local neighbourhood gullies that I could find to see what typical limiting capacity was. And typically 1 litre a second, and effective limit of rainfall intensity of that of about 180 millimetres now, some sort of midway between the other two.
Everyone who has worked on 2D models will know how brilliant they are, but how time consuming it can be to try and run a model, especially for the larger catchments. The good thing is you can get the routing if you've got the ground slope is taken into account, so the flow of where the water is going to flow is taken into account. But it's very, very time consuming, and we wanted to think of a way of being able to estimate the flooding, similar flooding, but in a quicker and easier way.
Hopefully is going to give a bit of context to some of the fantastic modelling work and others that we have heard so far this morning, and the collaboration that myself and the London Borough of Hillingdon and a number of other London lead local flood authorities have had with KISTers over the last few years, really to try and provide some real-time and local context to some of these national forecasts and understanding of the potential impact of surface water.
And there's a project called Future Drainage, and that's actually using these products to try and basically follow on from the UQUIA project that used the convex model, so that hopefully there'll be some good outputs coming from that can offer some new guidance in the future. This Future Drainage project will be able to give some new insights that build on that 2017 report. Yeah.
Okay, thank you, Stephen, and thanks to all our presenters for answering questions there in that Q&A session. And thank you all to all our attendees today for posing questions to our panelists. And for me, it's been fantastic to see the amount of further technology advances and pushes forward that we're bringing to the industry, which really will help, I'm sure, will help us meet this challenge of urban flooding. It's not going to be easy, and I think it's certainly going to keep the drainage engineers of tomorrow pretty busy for some time to come.
And so far we focused on storm overflows on day one, where we had some really great engagement and discussion on water quality, the challenges we face in dealing with stormwater and solutions around stormwater management. On day two, we introduced the new guidance for integrated urban drainage modelling, and we had discussions on impact of climate change and rainfall and developing solutions around flood warning. And a really big thanks to all of you who've been able to join us and attend and contribute to those 2 days. And it's been a cracking event so far. So this morning, I'd like to really introduce today's session topic, digital technologies in urban drainage management. And as you're undoubtedly aware, we all live in an increasingly digital world, and rapid advances in technology are disrupting established ways of working. And problems that we once solved by simply building something new are increasingly being tackled digitally or by applying technology to existing physical assets. Our UK water industry is at the forefront of this change, integrating digital technology now daily into physical assets. And our industry leaders are resoundingly optimistic about the opportunities presented by the convergence of the physical and the digital worlds.
So the question I've asked is, are we perhaps missing a step? And perhaps we can teach the machine what we know already, rather than it having to spend too long actually learning things.
So then just the benefits and the next steps. There is an aim for a wider integration of this system to drive continued improvement and network visibility across the company. And these monitors have given a wider understanding of this. And what it means is that the future interventions, maintenance plans, and investment can all be based on an informed basis, where quite often the sewer network's a bit of a hidden, it's underground. We know about the pumping stations, we know about the works, we know about the CSOs, but what's in between them, there's very little information on. So these monitors are allowing some of that to go forward.
And all the presenters today, really pleased that all of the questions kind of relating back to this challenge of presenting the thought around the digital opportunity that we've got within our industry. And what I really liked about that paper was about the work that you've done around the problem definition, and then you've developed that into a process. And it got me thinking about maybe, again, we should be, because we've got common challenges and common problems across the entire water industry, whether or not we should be starting to think about workflow mapping associated with those, like you've done there, Adam, and breaking that down into tasks and activities and the resource loading of those, and then even mapping those back into the business, into the benefits like you've defined at the end of the presentation.
So in the presentation, we're going to understand what the problem actually is, such as what we're coming up against every day. What issues do the problems present? Who and what do they affect? We're going to identify and examine some of the potential solutions, how they can be tackled from various perspectives, and how they can be implemented into InfoWorks and InfoAssets.
It's not the sexiest of the things you're doing in terms of mitigating the problems. People want to be reducing carbon emissions, not resolving the issues caused by climate change. So it is a challenge at the moment, and trying to get the funding to really push this kind of development along is a real challenge at the moment.
That's really a really good point. Yeah, so minimum viable product approach, and whether or not we got the processes in place to actually identify the investment. Something might be small, but actually could be significant. Thanks a lot for that. Andy, I think there's a question for you. Can we use machine learning to auto detect and alert the patterns and phenomena you've carefully observed in the data?
I think that's the next step as far as this pumping stations is concerned. We've gone down that route in relation to looking at CSOs. they've had less data associated with them. And here this is about using the data. If we can see things and patterns, and I think really this is about the idea that we've learned stuff over the course of time, using it as a tool for analysis within our engineering setup, and provided things as feedback into operations. So they've seen the outputs of this over the course of time. It's just don't look at the data. You really benefit from looking out and other things that you can bring in, those other perhaps sometimes non-digital things, and the human side has to be brought in. It's all being automated, but the human impact is that can't be right. The machine has got it wrong on this occasion, so to be able to guide it in that respect. So I think it's a big opportunity here.
Across the 3 days of conference, covering storm overflows, urban flooding, and today on digital technologies, it has been fantastic to hear about all the great work that has been undertaken in our field to advance the urban drainage industry. This is clearly only a sample of this continuous improvement, the innovations, and particularly the transformation that's going on in the digital field to transform our businesses. UDG is keen to ensure that we play our role and our part in supporting this work where appropriate, and as we move forward in our program of activities. Groups like UDG and other networks and panels are extremely valuable to CIWEM, as they are the technical cornerstone to their outputs, offering a forum for professionals to debate and the opportunity for members to meet, socialise and gain industry recognised CPD. For those of you who aren't members of CIWEM's Urban Drainage Group and who would like to know more information, we would invite you to get in touch with us. So the group is freely open to professionals working in this sector. Please go to the CIWEM website where you will find information on how to do that, or contact any of the CIWEM team or any UDG committee member.